It had the best of chimes and the worst of chimes, or worse yet, no chimes at all. It was the epoch of incredulity, the season of light emanating from a CRT. It was... Okay, with apologies to Dickens and classic literature in general, let's kick off this video, which is all about the infamous SID chip, the sound chip in the Commodore 64. Hello everybody, this is Jeff from the Ozark Mountains in Missouri, USA. How great was the SID chip? Well, revolutionary for a consumer electronics device. Having grown up in that era, I can attest that when the SID was shown off in 1982, other home computers and video game systems were struggling to produce basic beeps and boops. For example, the Apple II had a pathetic inbuilt sound capabilities until 1986, though you could pay even more to buy a sound card for it. The SID was so prolific, in fact, that it has been used in sound cards for other computers and in countless musical instruments and hobbyist projects. But I digress. This is really not about the history of the SID, but is about fixing the sound on your beloved Commodore 64. A couple of videos ago, I was testing a newly repaired breadbin by playing Jumpman and noticed that some of the sound seemed to be missing. I assumed this meant one of the channels in the SID was damaged. I also had another breadbin that I'd revived some time ago that was very, very quiet, and it seemed like a good time to look at both of them and find out about our good old friend, SID. It has been said that I can't carry a tune in a bucket, so I thought I should come up with some other way of judging how the SID was working rather than my untrained ears. I happened upon a little program called SID Bench, there's a link below, which tests out all three voices and the various filters and such, and after playing that I was convinced that I was right, that I had a missing voice. I came across one of BWAC's videos where he used Audacity to record the output of his C64s. I thought that was a great idea, so I installed Audacity and got to work. It occurred to me I didn't have a good baseline to compare to, so I used Vice and set it to 6581 SID mode and recorded the SID Bench program. Here's a brief sampling. And then I recorded the 6581 from a known good machine, and we'll play that back here too. Now that little bit of background sound you hear there is the audio input in picking up noise, and that was the subject of the last video. After recording the output of SID Bench running on Vice and 6581 mode and from a real machine with the 6581, I couldn't hear much of a difference, and looking at these waveforms here, I couldn't see much of a difference. There's a little difference here in the length of time it took to play, which is just because of the difference in clock speed between Vice running on my PC and the actual computer. So then I recorded Vice in 8580 mode and got out my 64G, which has kind of been my daily driver for quite a while now. And I recorded it too, playing SID Bench, and those looked pretty identical, and they sounded pretty identical. And the biggest difference that I noticed here, if we compare both Vice outputs, the 8580 and the 6581, we can see the filter performance in these regions is drastically different. And I think that's the sound difference I was hearing when I was playing Jumpman. I've been playing it so long on the 64G and hearing all the sounds that when I switched back to a breadbin with a 6581 in it, I happened to notice that something didn't seem quite right. I mentioned earlier that I had a breadbin that was virtually silent, and I've already taken it apart. This is it here. It has the 6581. And the first step in doing any repair is a visual inspection, so let's get to it. Okay, so we'll do our visual inspection here and accuse the shakiness. We're doing this handheld. Come in on the SID. which is here. Now, the SID is in different places on different boards, so if you check the service manual for your board assembly number, which this one is let me get to it here, 250407. It's kind of a reflection there. Maybe you can see it better there. And the assembly manual on the page or two just before the schematic, it'll show you a layout of where all the parts are. So that's a good thing to look at. So this is our SID, and everything related to this is kind of in this area, and then it goes back to the AV connector. So we do an inspection around there, and we pull the chip out, check for bent pins, things like that. And I've had a good look at this one. Oops, let me get a better focus here. Okay, there we go, focused a little better. So I've had a good look around the top side here and didn't see anything amiss. Now, I've worked on this board before, so I've already done this, but I thought it would be good practice just to show you how to go. Oh, what's this here? This looks like a bit of a splash on this capacitor. I'll take care of that. Okay, I got that mess cleaned up on the front of the board, which was from one of the tabs from the heat shield, flipping solder everywhere as I desoldered it. I'll zoom in here now on the SID chip area, which I marked with a dot. That's kind of helpful so you don't get confused when you're trying to find a particular chip on the back of the board. I kind of inspected all these connections around the SID chip. Everything going back here toward the AV port, and all of that seemed fine. After we've done our visual inspection, the next step is always to check that we have the proper power supply voltages to the chip. Now, the SID is a little unique in that it uses two different voltage supplies. It has the 5 volts, which is the 5 volts from the power supply, not from the 5 volt regulator that's on the Commodore 64 circuit board, and it has 12 volts or 9 volts, depends on the version of the chip that you have in the board. That 12 volts or 9 volts does come from the onboard regulator. So first thing we'll do is pick a convenient ground. I'm just going to go to the housing of the RF modulator, and we'll go to pin 28. I'm trying to keep my hands out of the way here. This should be our 12 volts. Have to turn on the power first. Okay, pin 28. We have 12 volts. Hopefully my big Charlie Brown head is out of the way so you can see the meter. And pin 25, which is our 5 volts. 28, 27, 26, 25. We have our 5 volts, so we know our voltages are good. Now, as I mentioned before, I could hear a very faint sound coming from my monitor when I cranked the sound all the way up, which indicated to me that the control signals were getting to the SID. It was an output problem. If you're not sure, you can always look at the data and control lines with an oscilloscope or logic analyzer or logic probe, just to make sure that all the lines are changing. Okay, now that the visual inspection is over and we've checked our voltages, we're going to check some other signals on the SID and try to get a better idea of what's going wrong. At this point, I've hooked up a keyboard, the video cable, and SD to IEC, so I can power up the board and run it and load a test program, etc. Before loading any test program, I've just switched the machine on. We can check the output voltage of the SID, which is pin 27. You see we have a little over 5 volts. You'll find that when you first turn on the C64 and you haven't turned the sound on or run any programs that use the SID, that this is going to be about half of the voltage on pin 28 So this is about 6 volts, which is about half of pin 28. Might be as high as 7 volts, it just depends. It's the audio output pin, but because if you've ever looked at like the graph of an audio output, it's a sine wave and it kind of goes like this. Well, this is a DC output, it can't go negative, so it biases that output about halfway up, and then it can go above that, and below that, and you get the same thing. And further on in the circuitry, there is a capacitor in series with that, which blocks that DC bias. So at any rate, we've got sort of what we'd expect from the output pin, and we still got no sound. Now what I'll do now is load SIDbench. Okay, here we have SIDbench running, and we're on pin 27 on DC mode, and you see we don't see a change. I'm going to go ahead and switch to AC mode. And really, once it stabilizes there, there's a little noise there, which is normal, but we're really not seeing any output at all from this pin, except you see a few blips there, and we hear it click from the monitor. Okay, now SIDbench is over. So if you have an oscilloscope, you can also use an oscilloscope for this, which is probably a little better tool. But even with a simple tool like a voltmeter with a true RMS AC scale, we can get a really good idea of what's going on. Okay, now the next check we're going to do, since we don't have any output voltage from the SID, is to make sure the output isn't shorted to ground somehow. So I've got the power switch on the C64 turned off. I have the power supply turned off. That's important because we're going to be using the ohms function on our meter, and we don't want the board powered up when we're doing this. If you don't have a power supply that you can turn off independently, then unplug the power cord. I've got the meter set to the ohms function, and I've got, I don't know if you can see it down here in the corner, I've got the common input on the meter to the DC ground on the board, and I'm going to check the positive on the DC ground, and you see we have about 0.2 ohms resistance through the leads, which is fine. Now I'm going to go again on the output pin of the SID, which is pin 27, and we have about 255, 260 ohms. I wasn't sure what this should be, so I checked on another breadband that was working, and it was about the same reading. I think it was 270 ohms there. So the point being that it's not a short, it's in about the right resistance range, so we probably don't have a problem past the SID pulling that output down so low that we can't hear it. Now at this point, we've looked at the board, done a physical inspection, we've looked at the power supply inputs to the SID, we've looked at the output voltage of the SID and saw that it's not really changing except for those few brief spikes which we could audibly hear. And the DC resistance of the output pin with the board powered off, the DC resistance is about right. This is kind of pointing us toward the possibility of a SID failure. So we'll swap in another chip now, and we'll repeat that same resistance check to make sure that we were correct there and what it should be. Now at this point I have the C64 turned off and I have my power supply turned off. If you cannot turn off your power supply separately, unplug the C64. You just don't want to do this with power on. I have this handy little chip puller that I've had since, well, let's just say for a long time when dip chips were still current technology. I'm going to pull that guy out of there. Now I've grounded myself. You'll notice I'm not wearing a wrist strap, but I have grounded myself to make sure I don't have a static charge. And I've got another SID chip here, which I know should be working. I got lucky and found this recently on eBay for about 15 bucks. Oops, that was not good. Pull it back out and check, make sure I didn't damage a pin. So $15 for a 6581 SID chip these days is really cheap. You see them going for 40 or 50 bucks on eBay. So, well, sometimes the pins are splayed and you can't quite get them in there, so if you put it on a level surface and you rock the package over like that, you can kind of get them all pointed back in. You're not trying to bend it a lot, just enough to line them all back up. One side seated. Okay, there we go. Now we've got our new SID in there. Since we're still powered off at this point and the power supply is turned off, we're still on the ohm scale. We will check pin 27. Yeah, this one's about 240 ohms, so pretty good there. I'm going to turn the power supply on, turn the board on. I don't know if you can see the little LED here on our PLA replacement. And I'll put the meter back on the volt scale. We'll check our voltage again to be double sure. 12 volts, 28, 27, 26, and 25. 5 volts. Okay. Now we'll load our SID bench test program again. Now we hear sound. Let's go ahead and check our DC output voltage. That's the filter, not because I'm touching the pin. So it's about 7 volts, and we go to AC. So you can see that on the AC range, our output voltage is changing quite a bit. You know, over a few hundred millivolts. It'll peak around 800 millivolts at really loud volumes. That last blip there was just because I took the lead off and had it in my hand. Okay, so this wasn't too bad of a fix. We did some simple checks, a visual inspection, which turned up some splashing of solder when I desoldered the RF shield on the bottom of the board, and we got that cleaned up, which had nothing to do with the problem, by the way. We did our visual inspection. Everything looked okay. We checked for power supply voltages at the SID. That was okay. We checked the output voltage. The DC bias of the SID output was what we expected without the board powered on. We checked the resistance of the output pin, and that was what we expected. And since the SID did something and there was a very, very, very faint sound, we kind of assumed that all the input signals to the SID were okay. So we swapped in another SID chip, which we knew was good, and that took care of the problem. We now have sound. If you have sharp ears, you would have noticed when SID bench was playing, there was a little bit of a crackle in the output. That's a deterioration in one of the filters on one of the channels of the SID. So I assume in a few years this chip will eventually fail, but for now it works. I've spent some time now playing Jumpman on it, and which is my favorite test program, and it works fine. Now I've already taken the liberty of measuring this output with Audacity, and it stacks up well against other SID chips that I know to be good, 6581s, and with the simulated 6581 from Vice. So I would call this a fix. Now I just need to put everything back together. Even though our fix for the last computer turned out to be rather easy, it was just a faulty SID chip, there are a few other components in the audio output that could be at fault, so let's take a quick look at those. Here you would see we have our audio out on pin 27, which is where we were measuring, and it feeds over into transistor Q8. Now this schematic is for the version of board we have, which is the 250407. If you have a different board revision, then you need to find the schematic for your board, else you're going to get very confused. At any rate, the audio comes into this transistor where it's amplified, and it goes out the audio output pin on the AV connector, and it also goes up this way to the RF modulator. So if you measure a good signal here at the audio out and nothing here where it goes out to pin 3, chances are you might have something wrong with this transistor here. The C13 right here is the capacitor that blocks the DC component of the audio output, that 5 to 7 volt bias that we measured. It blocks that and only outputs an AC signal to the audio output. A couple other things of interest that we'll look at are these capacitors right here. On my board, these are C10 and C11, and they are little green ceramic capacitors that are 470 picofarads. On some of the first Commodores, the early ones with the 5-pin AV connectors, they put 2200 picofarad mylar capacitors in there, or polyester, one of the two. They look a little different. They're taller and more plasticky looking on the outside. At any rate, they put the 2200 picofarad capacitors in there, and the result was that the filters didn't quite work right. They were kind of in the wrong range. The effect wasn't what they wanted, and it was wondered for a long time why Commodore put the wrong capacitors in there. After finding the datasheet for the 6581 and realizing they recommended 2200 picofarad, and reading more about how the 6581 turned out working good, but the filters and some things weren't quite what they had in mind, well, my guess is that they thought this was going to work with the 2200 picofarad polyester capacitors, and it turned out, after it was released, they realized those filters weren't quite acting like they wanted, and they did some testing and decided that the 470 picofarad worked a lot better. So if you have one of those older computers, it's worth looking at these two filter capacitors and putting their correct value in if they're not there. Also, if these capacitors were to fail, you might have strange artifacts in the audio out that's using filters, so it'd be something to keep in mind. The first Commodore 64 we looked at today turned out to not really have a problem. We did learn how to use Audacity to help track down SID problems and the difference in the filter response between the 6581 and 8580 variants of the SID. The second machine turned out to have a dead SID, and learning to measure the voltages and track down the problem so we could safely swap in a new SID chip wasn't too difficult a process, even with just a basic tool like a multimeter. I hope you found this useful. If you did, consider subscribing by clicking on the button below. If you subscribe, click on the bell icon, which is right there along with it, which will notify you when I do post a new video. And if you really liked what you saw, please consider clicking on the like button. I would appreciate it. Oh, and if you have any comments, leave them below. I'll be sure to get back with you. Thanks. Bye now.